let me show you the clear differences between primitive type of variable and the non-primitive type of variable. So let me just write a simple code to explain that. Here I have just a test class, and then if I do int n is 20 inside the computer memory diagram is that a storage is created. The label of the storage is n, which is a variable name. Inside the storage, the value is stored. So that's for primitive type of variable like int. And also similarly, if I define float, f is 3.1, we will get error because a 3.1 means a double type, so type mismatching. But suffix f will force this value as a floating point type. And then what happens is the same. So you have another storage created. The label of the storage is the name of the variable where value is stored there. So that's a primitive type case. But non-primitive type, like a string, if I do string s1, you need to create a string object, and then let's store ABC there, like that. Then what happens inside the computer memory is variable s1 is defined. The label of the variable, this storage is s1, and the new means an object is created depending on the definition of a class named string. And there a character sequence ABC are stored somewhere in the object. And then the new operator returns the location or address of this object, and that is stored in S1. So S1 is pointing to the location of a string object just created. In C++, this is called a pointer, but in Java, we call this one as a reference variable. So in Java, non-primitive type like string, the variable is always a reference variable, not a value variable. So value is not stored directly into S1, but only the address of a string object is stored. But primitive type is a value itself is stored inside the variable just defined. So that's the difference. So if I define another string variable, S2, and then if I do string with the same character sequence ABC, then what happens in computer memory is S2 is defined, storage is created, label is S2, a string object is created where ABC are stored there, and then address of the new string object is now stored in S2. So what is in S1 is the address of this object. What is in S2 is the address of this string object. So they are different locations. So if I try to compare, if S1 are the same, is the same as S2, then system.out.println S1 is same as S2, else, and then we say they are different. Then if I run the program, as you can see, they are different. In string, we use this assignment very much. So we have a shortened notation like ABC. This is allowed. Shortened notation is allowed. But this does not mean ABC is stored directly into S1. It never means that way. This is simply shortened notation for this. So even if I write this way, a string object is created like this. And then only the address or location of the string object is stored in S1 reference variable. So memory diagram is identical whether you do this way or that way. Remember that. So here if I run the program, they are different. So S2 we can use a shortened notation as well, ABC. Then if I run it, some interesting thing happens. If I run it, we get S1 and S2 are the same. but it does not mean S1 and S2 have those ABCs, but something like this. But computer compiler, the Java compiler, optimizes this code. Since S1 is pointing to string literal and string literal, those string literals are the same. So instead of creating another string object, compiler reuses string objects already created. So S1 is pointing the one being reused. Because of that, the address in S1 and the address in S2 are the same. That's why we have equal equal. But however, when you deal with a string, if you want to compare the contents in the string, ABC, never ever use equal sign because those are not guaranteed to be reused. Or if you use literal S1 and something like this, let me erase this part. If you have a literal ABC and through the computation you get another string object with the same string contents, but if you run it they will be never the same because the compiler does not optimize in this case. So how do you then compare two strings in contents? That is, you should use S1 and equals method. Equals method with another string object. So that's the way you should do that. And then system.out.println S1 equals to S2. So that's the way you should go. So always use equals method in string class. There. So now if I run the program, the addresses are different, but the contents are equal. So keep in mind that if you are new to Java, for primitive type int, you can use equal equal operator, but non-primitive type, never ever use equal equal. Equal equal is simply to compare two addresses, two references, not the contents. So always use a method provided for comparing contents. String case, that is equals a method. So keep that in mind.